Hey everyone, Mike here from ArnoldTutoring.com, and in this video we're going to talk about how the derivative of a function tells us something about the actual function. So here I've just drawn a random function here in blue on the right, and we're going to look at, again, kind of going back to first principles of what the derivative really means. What is the derivative? We call that the slope of the tangent, right? Let's write that up here just for us to always remember. Slope of tangent is what the derivative is. So if we take a picture like this, and we take any single point along the curve, let's say I take a point on the left side of the curve, right here. So that point in orange. Now if I draw a tangent to that point, again a tangent means it's hitting the curve at that point and that point only. I'll do my best drawing there. Let's look at this. This is a tangent line that's supposed to be a straight line in orange. And what's the slope of that line? Well, we don't really know exactly what it is. We don't have numbers or anything to deal with, but we can see it's going up and to the right. So that means the slope here is positive. This is a positive slope. Okay, now what does that tell us about the actual function? Well, you can see in blue as we go left to right, this is also kind of going up, right? As we follow the line here, it's going up and to the right. Which means that if we see a positive derivative, so I'm going to make this little table, if our derivative is positive, in other words greater than 0, so the slope is positive, that means that the function itself, f of x, is increasing. Let's take 1 second to talk about that. Again, if we see that a function is increasing, that means the derivative along that increasing portion must also be positive. Vice versa, if we find a positive derivative, it means the function at that point is increasing. Increasing just means going up and to the right. Okay. Now vice versa, we can see a point here on the right side. Let's see that point in green there. We can see that point if we draw a tangent to that point. That's supposed to touch the curve. We can see this is another straight line, but it's going down and to the right. So that means the slope, or the derivative, has got to be negative at that point, negative. And that happens when the function is decreasing, or going down and to the right. This is an absolutely vital thing to remember because they'll often give this to us in word problems or physics problems where they say, oh, well, you found that the derivative is negative. What does that mean about the object in question, or the motion of an object? And that means the motion, or its speed, usually is decreasing. So it's getting slower, something like that. Now, what happens, so we've talked about positive derivatives. That means the function is increasing. We've talked about negative derivatives. That means the function is decreasing. What's the one thing we're missing? Well, I will draw the point in red here, and it's right at the top. You can see that red point there. You can see that if I were to draw a tangent across that, it would be flat. That's supposed to be a flat horizontal line. And that happens at the very top of the curve. It would also happen if we had a different curve like this. It would happen at the very bottom of the curve. You can see that the tangent there is flat as well. So what does that tell us? Well, that tells us that what's the slope of a flat line? It's 0. So the slope, or the derivative of 0, means that we are at either a max or min. So either a local maximum or a local minimum of the given function. And this right here is the most important part of the table. We're going to do many optimization problems. This will be huge for curve sketching. We need to know that if we are at a maximum or minimum on our curve, that means the derivative at that point is 0. Now, one last point is that it does not work the other way around. So if we find that f prime of x equals 0 at some point, this does not guarantee a max or min at that point. And we'll talk about that a little bit later, but it only works the one way around. So you find the max and the min, and it's differentiable at that point, then the derivative has to be 0 at that point. If we can keep this table in mind down here, the relationship between f prime of x and f of x, so what the derivative tells us about the function and what the function tells us about the derivative, that's going to make everything we do further in this course much, much easier. Hopefully this is helpful. We'll talk about the second derivative in the next video. Thanks.